In this video, we're going to learn how to graph the tangent function. So I've set up my unit circle, and for the sine and cosine function, we only really used our quadrantal angles. So let's calculate the tangent at our quadrantal angles. So the tangent of 0 radians is y over x, which is 0 over 1, which is 0. The tangent at pi over 2 is going to be 1 over 0, or undefined. Well, that's an issue for us because we can't really graph something that's undefined. So we're going to come back to that in just a second after we finish all of our quadrantal angles here. The tangent of pi is going to be 0 over -1, so it's going to be 0. The tangent of 3 pi over 2 is going to be -1 over 0, so that is also going to be undefined. And then when we come back to 2 pi, the tangent of 2 pi, that's the same as the tangent of 0 because they're coterminal angles, so we get 0 again. So let's just go ahead and plot these points. Let's label the graph here. And I'm going to label it 0, pi over 2, pi, 3 pi over 2. And you notice I kind of run out of space because I skipped some spots. And I skipped spots for a particular reason, and you'll see that in a second. But I do want to get 2 pi in there, like a whole 2 pi. So what can I do with these 7 pi over 4? Like 7 pi over 4 and 2 pi. Well, down here I've made a couple of circles around 7 pi over 4. I calculated a quadrantal angle backwards to be -pi over 4, and right here backwards would be -pi over 2. So that's what I'm going to do. I'm going to go backwards and do -pi over 2. And this whole distance here then ends up being 2 pi. All right, so let's just go ahead and plot what we know. So if I'm going to go ahead and plot tangent of 0, that is at 0. I'm going to plot tangent of pi, I know that's at 0. Tangent of 2 pi is also at 0, but that's coterminal with 0. What do I do with these undefined? Well, when we have a value at a particular x value that's undefined, like if we plug in an x value and we get something that's undefined, we call that an asymptote because we're not allowed to plug that value in. That value for x is not in our domain. All right, so if I went backwards, -pi over 2 is the same as 3 pi over 2, and 3 pi over 2 is undefined, so -pi over 2 is undefined for tangent. Pi over 2 is undefined, and 3 pi over 2 are undefined. So these x values are not in the domain of our tangent function. They will always have asymptotes. Tangent will always have asymptotes. So let's go ahead and label these. This is x equals 3 pi over 2, x equals pi over 2, and x equals -pi over 2. All right, so how do I graph the rest of this? Well, if I only looked at my quadrantal angles, I would only know where this function crosses the x-axis, but I need to know a little bit more about my function. So what I did was I added other values into what I'm going to graph, and those are my pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 angles. So when I find the tangent of pi over 4, since that's rad 2 over 2, comma rad 2 over 2, those values are the same, I get 1. When I find the tangent of 3 pi over 4, one of those coordinates, the x, is negative, so I get -1 when I take that ratio. if I find the tangent of 5 pi over 4, both of those x and y values are negative, so I get a positive. Tangent's positive in Q3. And now I'm going to use my negative angle, negative pi over 4. Well, I have a negative y value, but a positive x value, so that's going to give me a negative 1. So I'm going to go ahead and label these other parts to my graph. 5 pi over 4, and if we go backwards, it's negative pi over 4. So let's go ahead and plot those points. At pi over 4, I have 1. I'm going to label 1 right here. Actually, I'm going to label it down. Let's label it right here on this one. Okay, so at pi over 4, we're at 1. At 5 pi over 4, we're at 1. At 3 pi over 4, we're at negative 1. And then at negative pi over 4, we're at negative 1. And we can go ahead and do the same thing that we did for the sine and tangent function. We can calculate points and see how the graph looks at those points. But because I know a lot about asymptotes, I will tell you that the graph is going to curve up and approach my asymptote, curve down here and approach my asymptote. So it's going to look the same way over here. It's going to curve up, then curve down to approach the asymptote. Okay, so let's evaluate this graph now. The period of this graph, right, is the smallest distance along the x-axis that includes a complete picture of the graph, but no duplicate. So I would say that this graph, a whole piece, can be found from negative pi over 2 to pi over 2. That it has a distance of pi. The period of tangent is pi. Unlike our sine and cosine, our sine and cosine period is 2 pi. So let's go through some steps in graphing. How do we graph the tangent function given an equation? This, by the way, this equation was just a basic tangent function. Y equals the tangent of x. Okay, so when we graph our tangent function, we're going to be interested in finding the beginning and the end of our period right here, one period. Those will be our asymptotes. We will break our period down into 1, 2, 3, 4 equal parts. We must label the quartile, the half, and the 3/4 marks on our graphs. Okay, and we need to plot those points only, and then we'll draw our graph in. All right, so let's go through our steps. Well, if our equation looks like y equals c plus a tangent of b times x plus d, here are the steps to plot. So in step 1, it says find all values of a, b, c, and d. You should definitely go and find, c is going to be your vertical shift. Our tangent function, let's go back to what it looks like. Our tangent function does not have an amplitude. An amplitude is defined from a resting position to the maximum or minimum point. Our tangent function, there is no amplitude, but that doesn't mean we can't stretch the graph. We can still stretch and compress our graph. So while C is still our vertical shift, A is going to be our stretch or compress factor, B is going to be what changes our period, and D, or phi, I like phi, is going to be that is going to be our phase shift or our horizontal shift. All right, so we find our values of A, B, and C. Once we find our values, if C is not 0, we should mark our vertical shift using a dashed line on our graph and label it with the equation. Step 3, we should find the beginning and the end of our first period. because that is where our asymptotes will be. And we need to draw our asymptotes in. Once we find the beginning and the end, those will be our asymptotes. Draw those in using a dashed line and label them with their equations. Step number 4, it says calculate the quarter, half, and 3/4 labels, because these are where we're going to plot our points. Write them on your graph and plot points at these marks. Then it says to calculate your period. Your period is calculated as, because our period is not 2 pi for tangent, it's calculated as pi over b. And then check this against the width of your graph. Make sure that when you take your end minus your beginning, so end minus your beginning that you calculated, it should equal your period. Okay, and then if you need to plot another period, go ahead and plot another period. So I think we'll have time, just enough time to do a basic graph, and I'll then go ahead and make another video for the other examples. All right, so A, B, and C. A is going to be 2. A is not 2. A is 1. A is the number in front of your tangent. B is 2. C is 2. And D is 0. So we have no stretch or compress, and we have no horizontal shift. All right, so let's go ahead and find the beginning and the let's plot our vertical shift. We have a vertical shift at 2, y equals 2. And now let's go ahead and find the beginning and the end. Remember, this time we're going to set what's in these parentheses right here in our function. We're going to set that equal to negative pi over 2 for the beginning. For my end, we are going to set that equal to pi over 2. So when we solve for x, we're going to divide or multiply by 1/2, so we get a negative pi over 4. We'll divide this and we get a pi over 4. So I know I have to divide my graph into 4 equal parts. So if I put negative pi over 4 here and pi over 4 here, I only have 2 equal parts. So I'm going to spread them out a little bit more to give myself some room. Negative pi over 4 and pi over 4. And I'm going to draw in my asymptotes and label them with their labels. X equals negative pi over 4. X equals positive pi over 4. My halfway mark is 0, and if I divide pi over 4 into 2 equal parts, this is pi over 8 and negative pi over 8. You can use the midpoint formula to find that. All right, so I need to find the tangent at 0. And the tangent at 2 times negative pi over 8, and the tangent at 2 times pi over 8. Well, tangent at 0, we already calculated that, is 0, but I have to add the 2 to it. So I get 0, 2. Tangent of 2 times negative pi over 8 is negative pi over 4. We saw that was a negative 1. Negative 1 plus 2 is 1. And then I have the tangent of 2 times pi over 8 is pi over 4. And then I have to add the 2. Pi over 4, the tangent of pi over 4 is 1. So when I add the 2, I get a 3. All right, and you can see I'm going to go ahead and draw my graph in here. Okay, so now if I wanted to calculate another period, I just count off 1, 2, 3, 4 of these. 1, 2, 3, 4. I need to figure out what this label is going to be. I believe this is going to be 1 pi over 8, 2, 3, 4, 5, 6 pi over 8, or 3 pi over 4. That will be another asymptote. X equals 3 pi over 4. I'm going to mirror my points. This is 3 pi over 8 or 5 pi over 8. And this is going to be pi over 2. and I'm going to draw my graph in.